Hello and welcome to a video explanation of this simulation circuit. My name is Einar Pérez Concha and I'm from the Universidad Politécnica de Yucatán. I'm studying Embedded Systems Engineering at the 6th quarter. So here we have a circuit that is basically showing us an example of signal conditioning using the type of amplification, right? There are many types of signal conditioning or types of conditioning your signal, but in this case we'll be using the amplification one. So what does that mean? Basically we have our temperature sensor, which is a LM35, and also our amplifier, which is 358. So these are our main elements, having the temperature sensor as the one that will be amplified and the amplifier as the one that will make the amplification. So we know that the temperature sensor, based on his datasheet, that this sensor delivers millivolts in its output. So that's not too good. In electronics, for instance, you can most of the times you can work with that low voltage, right? Millivolts is not enough for most of the microcontrollers nowadays, so that's why we are amplifying it in order to work with a high voltage. Yeah, the sensor is at 27 degrees Celsius, and it has been powered with a DC source of 5 volts, and it works with that. It works in a range of 4 to 30 volts, so it's no problem working with 5. Also, the amplifier is powered with the same source and grounded, both of them, in their respective pins. So yeah, we'll be measuring the output of the temperature sensor with a voltmeter, and yeah, this will be showing us the input voltage of the whole circuit, right? The signal conditioning circuit. And also we have another voltmeter connected to the output of the amplifier, which is also the output of the whole circuit, the signal conditioning circuit. So this will basically show us how the output of the temperature sensor will change after the amplification, right? How much it has increased, for instance. Well, this amplifier is a non-inverting amplifier configuration, and we have the R1, which is connected to the inverting pin, and also an R2, which will work as a feedback connected between these two and the output of the amplifier. It will be constantly feedback in the amplifier. Okay, so yeah, as I explained, you have a low voltage here, which is the output of the temperature sensor, and an amplified one. It will increase in this case. The amplification will increase the output voltage of the temperature sensor. So let's take a look at the simulation. I hope it doesn't close. And there you go. Let me pause this. You have a 0.7 input voltage and 3 volts in the output, meaning that it increases indeed. So how much increases? You can calculate that by dividing 3 over 0.27, sorry, and you'll get the gain of the whole circuit, how much it increased. Or you can also use a formula where you would be using the resistors, and that's equal to gain is equal to 1 plus R2 over R1, and that will also give you the gain. Thank you. Like and subscribe the video if you like it.